Hi, in this video we're going to identify a quadratic graph that best matches a given equation. So we're given the equation of a quadratic graph here, and we're trying to identify which of these four graphs is the best match for this equation. Remember, a sketch of a quadratic graph is when we indicate the intercepts with the x-axis and the y-axis and shows a general shape, but we don't have other than the intercepts, we don't have a scale on the axes. So it's just indicating the general shape. Right, now remember what we know about quadratic graphs when we're sketching them. If I was to have, we either have a smiley face shape like that, if we're plotting a quadratic graph, or a sort of hill shape like that, or a frowny face. And remember, we get the first shape if the number in front of the x squared, known as the coefficient of x squared, is positive. So when we had y is equal to something positive, so positive a, positive 3, positive 1, x squared, etc., then it's this smiley face shape. And it was negative, so like y equals minus x squared or minus 3x squared, etc., then it's going to be this hill shape like that. So let's look at this equation here. It's in factorized form, but if we consider the expansion, can you see if we did the 4x multiplied by this minus x, that would give you the x squared term in the expansion. And 4x times negative x is going to be minus 4x squared. Now, that's a negative number, so therefore, it's going to be an example of this. So we can instantly get rid of some of these. It's going to be an upside down shape, so we therefore know it's not going to be that one because that's a smiley face shape, not a hill shape, right? But it could be one of the other three. Now, also note that we can work out the x-intercept from this, also known as the roots. And the way we find the x-intercepts is to make the y value 0. We've seen that in previous videos, because you can see when you're on the x-axis, the y value is 0 for any point in the x-axis. And you can use that to work out what these x-intercepts, also known as roots, are. So let's do that. If we've got y is equal to 4x minus 3, 2 minus x, on the x-axis, the y value is 0. So we say when y is equal to 0, we've got 0 is equal to 4x minus 3 multiplied by 2 minus x. And remember, when we have a product of two things times together to give 0, then at least one of them has to be 0. So if the 4x minus 3 is equal to 0, remember the quick way of doing it is you can just negate the constant term. So you negate this to become plus 3 and divide it by the number in front of the x. So it's going to be positive 3 over 4. So x could be positive 3 over 4. Or if the 2 minus x was 0, well, 2 minus what is 0? Well, it's 2 minus 2. So you can see that x is equal to 2. So those are the two roots, the two x-intercepts. So we got 2 and 3 over 4. Now, what could that be? Well, it could be the 3 over 4 and the 2 the x-intercepts on this graph, like that. Now, it can't be graph 1, you can see, because it only has one x-intercept. It's like touching the x-axis at that point. So there'd be only one x-intercept rather than two, the 3/4 and the 2. So we know it therefore can't be this one. We also know it can't be graph 3, because can you see that one of these x-intercepts is 0? But our x-intercepts are actually 3/4 and 2. So it can't be graph 3, and therefore it must be graph 2. That is the final answer.